So what's going on YouTube? Today I've got a practical Scapy tutorial on as-web rustling detection. I initially considered using Suricata, but since there are already comprehensive guides on detecting this attack with Suricata, I decided to take a different approach. While more sophisticated SIEM and intrusion detection system exist, Scapy is a valuable tool for demonstrating the basic principles of as-web rustling detection and performing initial analysis. Remember that as-web rustling is essentially a brute force attack. This means a key part of detection involves identifying a high rate of as-web requests originating from a single IP address, targeting multiple user accounts within a short time frame. First, let's verify if we can extract the information we need from the PCAP file. Did you know you can quickly search for a specific strings using the IP contains filter? Looking at the PCAP, we can confirm that the user accounts appear in plain text. Now, let's process this PCAP file with Scapy. Before we start coding, let's explore how to extract the information we need using Scapy. When I first tried Scapy, I was completely lost after reading the PCAP file. So I hope this will help you understand how to effectively work with Scapy. Okay, let's verify that the PCAP file loaded correctly. We need to iterate over the PCAP to read these details. We can use a for loop like this. We need to access the Kerberos information, which means we will need to specify this section for each packet. As the error message indicates, the packet I'm trying to read doesn't contain Kerberos information. We can simply skip these packets like this. I use a try except block because not every packet will contain Kerberos data. Using has layer would be a more elegant approach than try except blocks, though either method works fine for this small amount of code. Let me explain this example in simpler terms, even if you are new to packet filtering with Scapy. We've already specified the Kerberos information using Kerberos. And now we'll retrieve the principal name to access the user accounts. We specifically use KRB KDC rig body to correct the human accounts. Without this, we'd retain the as-web information, which we don't need. I mean, we are interested in the usernames used in the requests, right? So, how can we access the name string property? We can access the name string property this way. Since we don't need the ASN1 tag, let's explore how to extract just the username. Since this appears to be a list object, we should be able to slice it to get what we need. I'm not sure why the outputs appear corrupted. Scapy objects are often trickier to work with than ordinary Python objects, but there might be a better approach. When I encounter unfamiliar objects, I explore their capabilities and methods like this. So the output says that we can call val method. This sounds like we are looking for. Okay, great. Since all the information is in binary format, I'm converting it to strings. Now, let's put our findings together in the Python script. Here's a simple version that's very useful for quick analysis. At a glance, we can easily see when events occurred and which accounts were involved. This enhanced version includes detailed descriptions. Sometimes the SRCIP field may not accurately reflect the attacker's IP address. That's it for today's ASREP roasting detection. Thanks for watching.